Let's do part C here. In a different experiment, the club head is in contact with the ball for a time of 220 microseconds, right? So our time is 220 times 10 to the minus 6th seconds, right? Wow, that's not very much time. Has a mass of 0.17 kilograms, the club head does, right? And the ball has a mass of 0.045 kilograms. At the moment of contact, the ball is at rest and the club head is moving at 38 meters per second, and the ball moves off at 63 meters per second. So the first thing says, calculate the average force acting on the ball while the club head is in contact with the ball. I love this. So this is force times time is mass change in velocity. Okay, the force is what you're trying to find. The time is going to be the 220 microseconds, sorry. And then it's the force on the ball. So we're going to use the ball's mass, right? So plug that in there. And then the ball's change in velocity is this, right? So plug that in there. And you should get the force, right? The force is between 12,000 newtons and 13,000 newtons. But remember, we only have 2 sig figs, so round it to 2 sig figs. Okay? So there's some answer, right? Force equals newtons. It'll be in the tens of thousands of newtons. Okay. Now it says state the average force acting on the club head while it is in contact, right? Well, it's 1 mark, right? So they're hoping that you'll say whatever this force is. Say this force is positive 5 newtons. They want you to say that this is negative 5 newtons. It's not 5 newtons. Okay. It's much, much more, but whatever it is, right? And in fact, you have to put the minus sign on there, okay? Without the minus sign, I think you don't get the mark, right? I wonder if you said like this was to the right, if you said this was to the left. Certainly if I was a person marking this, I would break the rules and do it. So this force is in the opposite direction. So the golf club hits the ball, right? The force of the club on the ball is that way, right? The force of the ball on the club is this way. These are equal and opposite force pairs, right? And then it says calculate the speed of the club head at the instant that it loses contact with the ball. This is interesting, right? So this is a momentum thing, right? So before you've got the club head moving, ball sitting still, right? Afterwards, you've got the club head moving at some different speed, right? We don't know what that is. And the ball's moving lickety-split this way, right? Here it's going V. Here we know the ball is going, what 63 meters per second? Right? And then the ball is at rest. Okay, there we go. So we know this is 0 meters per second. And we know this is 38 meters per second. This mass is 0.17. This is 0.045. 0.17. 0.045. All right, and what you're going to do is you're going to set up a momentum expression. This is just simply momentum, right? So you're going to go m times v, that's 0.17, right? Plus m times v, of course this is 0, equals m times v plus m times v, okay? And you'll see that this thing is, of course, going slower because the ball has some of the momentum, but not all of the momentum. The answer I got was between 20 and 30 meters per second, okay? Anyway, good luck. So this is just going to be P is mv, right? So mv plus mv equals mv plus mv. Figure it out. You can do it. This is well within your wheelhouse. What does that even mean, wheelhouse? Anyway.